What if I told you that the very technology meant to safeguard our environment might be misreading the signals we depend on? Imagine if the air you breathe is contaminated because AI is misinterpreting spectroscopic data. It sounds like a plot twist from a sci-fi movie, but it's happening right now. Many people don't realize how serious this issue is. We trust these systems to monitor pollution and track climate change, yet there's a hidden flaw that could put us at risk, potentially causing us to miss critical warning signs with devastating consequences. Picture this: you're out for a walk, enjoying the fresh air, while sensors are supposed to detect harmful chemicals around you. But what if they're failing? What if A misreads the data and falsely reassures everyone that everything is fine when it's not? This is a reality that many environmental scientists are beginning to confront. The problem lies in how these A systems analyze spectroscopic data. They are trained on vast datasets, yet they can still overlook subtle changes in our environment. A small error could lead to significant oversights, and what seems like a harmless shift in air quality could go unnoticed until it's too late. Imagine a community being told their river is clean because the data shows low toxicity levels. But if those readings are incorrect due to misinterpretation, how long before someone gets sick? It's a chilling thought that raises an important question: how many other wrong assumptions are we making based on faulty data? As we delve deeper into this issue, the tension grows. What happens when fragile ecosystems are overlooked? The potential for disaster increases with every misread signal, putting local wildlife at risk and exposing entire communities to unexpected health crises. However, there's a glimmer of hope. Scientists and tech experts are aware of these challenges and are working diligently to improve AI training methods. They're developing new models to enhance accuracy and reduce the risk of misinterpretation. But here's the catch: implementing these improvements takes time, and the clock is ticking. And the improvement So what can you do? Stay informed. Advocate for transparency in environmental monitoring. Demand accuracy from the organizations responsible for our air and water quality. Your voice matters. In the end, we must ask ourselves, how much do we trust the technology that's supposed to protect us? Understanding these alarming signals is just the beginning. It's up to us to ensure we're interpreting them correctly before it's too late. Have you ever wondered how much we can truly trust the data we receive? A tiny change in a reading could mean the difference between a healthy ecosystem and an environmental disaster. Now, there's a troubling reality in environmental monitoring: misinterpreting spectroscopic data. Most people aren't even aware of this issue, but it's quietly shaping our understanding of the environment. Imagine yourself as a scientist in a vibrant forest, equipped with cutting-edge technology to analyze air quality. You expect the data to provide clear insights. But what if A, which we view as a helpful tool, might be distorting those results? This problem is more common than you might think, raising serious concerns about accuracy and reliability. Let's dig a little deeper. Spectroscopy is designed to clarify complex compounds into understandable data. However, when A gets involved, it often misinterprets these signals. Could a small glitch lead to a major mistake? Unfortunately, yes, and it can happen all too easily. For instance, imagine an A system mistakenly identifying a harmless gas as toxic. Suddenly, You're evacuating an entire town based on incorrect information. It might seem like a simple error, but consider the fallout panic, wasted resources, and disrupted lives all stemming from a misreading. But who's to blame? Is it the technology, the data, or perhaps a misunderstanding of how these systems work? Each mistake adds to the risk, creating a snowball effect that extends far beyond the initial error. Many people believe AI is flawless, but it relies on patterns and often misses crucial details. Imagine trusting your car's apps only to find it leads you into a restricted area. Scary, right? The same principle applies to environmental monitoring. As the stakes rise, so does the tension. We're at a crossroads where our trust in technology conflicts with the need for accuracy. What if the very systems designed to protect our planet end up putting it at risk? But don't lose hope just yet. Awareness is the first step toward change. By recognizing ACE limitations and being cautious in how we interpret data, we can foster a conversation that prioritizes safety and accuracy. So, the next time you hear about innovative technology in environmental monitoring, remember not everything is as straightforward as it seems. Knowledge is power, and questioning the norm might just be our best defense against misinformation. Consider this: could your trust in technology be putting the planet and your community at risk? As we continue exploring this topic, let's stay alert. Your awareness could truly make a difference. Imagine standing in a beautiful field, breathing in the fresh air, completely unaware that your surroundings might be hiding a serious secret. What if the very data meant to protect us from environmental disasters is actually misleading us? Most people tend to trust what they see. But what if I told you that artificial intelligence, which analyzes spectroscopic data to detect pollutants and inform us about air quality, might be making significant errors? You might wonder, how could this happen? The answer is simple. As AI systems advance, they encounter complexities in spectroscopic data that can easily escape human notice. This misinterpretation can lead to disastrous decisions. Picture a small town relying on AI to monitor its air quality. One day, the data shows everything is fine, but just weeks later, residents start experiencing health issues. How is that possible? It turns out the AI flagged a false positive, missing a hidden danger lurking just beneath the surface. This scenario could unfold anywhere, impacting your community, your health, and the well-being of your loved ones. Let's dig deeper. Deeper. The algorithms we depend on are trained on imperfect data, making it easy for them to overlook critical spectroscopic signatures, which can create a false sense of security. The consequences of this oversight could be severe. Imagine a scientist detecting a sudden spike in a hazardous chemical, only to find that our monitoring systems completely missed it. You might feel